Hello everyone, welcome to today's session. So today's session will be discussing about the data sets and its types, descriptive statistics mainly. We'll try to understand the differences between continuous data, discrete data, categorical data, qualitative data, numerical data, quantitative data. Now first thing is, last session we have discussed a lot about data pre-processing. Now in continuation with that, now we are going to understand a little bit more about the data. Now before we go into the data, now these are some of the terms that you should be knowing when you are implementing your project in ML, in machine learning, or in data mining. So basically, what is descriptive statistics? Now descriptive statistics, it's actually, as the word itself says, is a branch of statistics that does data set summarization. So basically here you'll be able to, using this method, you'll be able to summarize and describe your data. So these are just descriptive. This is just statistics. Here we are not talking about any machine learning algorithm and how it works. So basically this is just a statistical information about your data that describes your data. Next is data visualization. So data visualization, basically it's a study of a branch of study that involves investigation of data. So mainly you have plots which will explain and present the data to the customers. Now again you have descriptive analytics and data visualization techniques. Now why do we have this? Because it helps us to understand the nature of the data. It further helps us to determine which kind of ML or data mining task that we need to use to understand the data. And basically this step is also known as EDA. EDA stands for exploratory data analysis. The focus of exploratory data analysis is to understand the data and prepare it for machine learning algorithm. And exploratory data analysis involves or includes descriptive statistics and data visualization. Now basically today's session we are trying to understand these basic terms because we will be using these words later on when we are implementing our algorithm. So basically descriptive statistics is about statistical information about your data. Visualization is all about plotting. And why we do this? In order to do EDA. Now EDA is all about understanding the data so that we are able to prepare the data for further machine learning algorithms. Now coming to data sets, let's try to classify the data, right? So you have collected your data for your machine learning project. Now you need to understand your data, what type of data sets, what type of data it is, right? So now the data you might have collected, it can be a record, it can be some kind of vectors, event cases, some kind of observations. Now suppose I have a let's say an Excel of data, and in Microsoft Excel I have some numerical data. So let's say each row we can say it's a record because it will contain some attribute information. Now what is attribute? Attribute is basically going to define the characteristics of the object, and it will have some kind of a value. And very important that every attribute will have a data type. So the data type of your you're very important that you understand the type of your data set. So the data type can be categorical data, it can be a numerical data. Now categorical data can be either again classified into nominal data, ordinal data. Numerical data is again classified into interval data and ratio data. Now let's see each of them. First one, coming to categorical data. Now categorical data is also called as qualitative data. That is again, as I told you, can be classified further into nominal data and ordinal data. Now what is nominal data? Nominal data is a data which will be having some kind of symbols. It cannot be processed like a number. Okay, it will have symbols. There will be no number here. For example, if I have a patient ID of a patient, now that you are not going to do any math equation on that. It's just a ID of the patient. It can be numbers, it can be alphabets, whatever it is, it's just a symbol. We are not going to process it like a number. The only kind of processing that you can do on nominal data, probably equal to or not equal to. So I can write, if the patient ID is equal to 100, I'll be doing this. If the patient ID is equal to 101, I'll be doing this. So that's the maximum operation that you can do on nominal data. You're just checking for equality and nothing else. The second one is the ordinal data. Ordinal data is all about information, right? So for example, it provides information. For example, fever, right? What are the three values that it can have? Low, medium, high. So these are the, basically has some kind of information, and there is a ordering here: low, medium, high. So irrespective of the value, right? Whatever value, low means it can be 93, 99 Fahrenheit, medium may 100. I am not irrespective of the value, I have just given some kind of a information that this is low fever, medium fever, or high fever. And here the ordering is very important. So that is ordinal data. So coming to the next next kind of data, we call it as numeric data. As the word itself says, it can also be called as quantitative data, and this is further classified into interval type and ratio data. Interval data means basically this is a numerical data. You will have numbers here, but what is the possible operation that you can have here is I can have, suppose, temperature. I will have 30 degrees, 40 degrees. Okay, so it's a numerical data, and I can take difference here, I can do addition here, I can do subtraction here. Now ratio data, now this ratio data, now here you can have differences as well as you can have ratio. See, the word itself says interval data means what? It is the interval. You're going to find out the difference between the values. But ratio data means you can take the ratio, you can also take difference. Okay, so basically it's the difference between ratio data is the difference between ratio and interval data. Okay, suppose centigrade to Fahrenheit conversion you have to do. So zeros of both scales will not match, right? Centigrade will have a different zero scale, Fahrenheit will have a different zero scale. Hence these, we can say this is an interval data. Okay, now coming to the next categorization of data, next type of data set, you can have discrete data and continuous data. Discrete data means here you will have data recorded as integers. For example, you have taken survey of some employees or employee identification number. Let's say identification number is 1001. This is a discrete data. So you have recorded data, it is in the form of integers, but it's a discrete data. Now continuous data means you will have a continuous range of values that can be fitted into a range. For suppose a patient height, right? The height of the patients in your data sets, you will have a continuous range of values. The weight also can be continuous, right? It may also be discrete. Now the age can also be discrete. You can 12.5. It can also be continuous, right? If I take the patient height over the last 10 patient weight over the last 10 years, you can see the weight will be varying. You'll have a continuous value. So that's a continuous value. Okay, so there's another classification of data which we call it as univariate data, bivariate data, multivariate data. Now each one of this we will see in the next sessions. Univariate data, it means the data set has only one variable. Okay, it will have only one category. Bivariate data means it will have two variables or two categories. Multivariate data means it will have three or more variables. So basically this is another classification of data. So each one of this we will see in the next sessions. So that's it for today's session. So today's session was a quick demonstration of different classifications of data. So to quickly revise, right, one classification of data that we saw was categorical data and numerical data. Under categorical, again we had ordinal data and nominal data. Under numeric we had interval data and ratio data. One more classification that we saw was discrete data and continuous data. And another classification of data that we are going to see again in detail in the next sessions are univariate, bivariate and multivariate. So thank you so much. Please stay connected for a complete tutorial of this machine learning course. Thank you so much, and please subscribe. Thank you.